Hi everyone, this month. Today we're going to talk about some cool things like what are some challenges in deploying computer vision models. So you can see the talk like the notebooks to production. So it's really difficult as an ML engineer or let's say a data scientist to make models to production. So we're going to we're going to discuss some cool things. Like we're going to see some challenges. What are some challenges deploying normal ML models and also models specific to computer vision, and also we'll just look at some open source tools. So it's quite overwhelming to work with a lot of open source tools available, especially for MLOps. So it's really hard to pick one for our use cases. So we'll just look at some open source tools available, and also what are some best practices when we're just trying to deploy the model, and also especially when we're trying to make bring some models from notebooks to production, or let's say when we're just trying to deploy the models, we should have a certain kind of tool that helps us to manage different kind of MLOps tools, like which can bring all these tools together, which and help us to build an entire application. So we'll just look at that as well. And about me, like I'm an ML engineer as well as a developer advocate, like a freelance developer advocate. I just love advocating for open source tools. You can just find me on Twitter, YouTube, creating a lot of content around data science and ML. This is my Twitter handle. So yeah, and also like you can just find me on Twitter. Like I just love to connect with you all. And also I'm just started this community called C4ML to help the people getting started with data science and ML. And now it's just around 700 people on Twitter and also around 250 people on Discord. So just the intention is to help people who are just getting started with data science and ML, like as me, who just faced the difficulties. I just thought cool to create a community that help each other. So you can just find that Twitter link here, like C4ML. You can just try to join the community and be part of the events as well, like cool events we used to conduct. So you can just participate that as well. So yeah, to give some quick context to this talk. Like the general ML lifecycle, what we used to thought is generally probably in the audience, you may be aware of. It's not just about a one-way traffic. Like it's not just about like creating the model and just deploying that. It's just more than that. Like the general procedure is like we used to define a problem. We used to collect the data. We used to, if it is a computer vision model, we used to annotate that. We used to do some manipulation if it is a tablet data, and also after that, we used to train the models and evaluate that if it works good, and we used to deploy that, right? But that's what most of us think when it comes to ML lifecycle. But it's not just about creating the model and deploying that. There's a lot of things to be done once you just deploy the model. So it's just about coming back, reiterating based on what's the result that you just got. Keep continuously monitoring your models and just reiterating the previous things, like it can be retraining the model, it can be collecting some more data, etc. So it just to give some context about how the ML lifecycle. And also we as a data scientist, we just love to write some code and just want to see some cool applications, right? Like we just want to write some cool code. It can be some computer vision application, NLP, whatever it may be. Just want to write some code, and we just love to see some cool results in the end, like in the developer end. But it's just not possible. There are a lot of things involved when we're just trying to create an end-to-end model. Probably we'll just look at some challenges in general ML lifecycle. Probably we can just go to the problem specific to computer vision as well. So obviously, as we just seen in the ML lifecycle, it's just not about every step, like every step is a challenge, right from problem defining to data collection, processing, argumentation, whatever it may be. Like every step is challenge. So to give an idea, probably with computer vision models, we used to collect the data, but maybe in the we won't be able to find a right set of data for our application. There may be some kind of challenges in the data collection, as we all know. Like whatever we just give the data to the model, it will just replicate that, like the model, how well the performs, it's based on the how good the data is. So it's really important to collect a right set of data. And also when it comes to pre-processing, right, we just have a lot of things to be considered to iterate and to produce some good like to better model. Like I'm not going details as of now, like we'll just more look into some production level. Like I'm just giving some quick context, like what are some challenges in ML lifecycle. So that's for that. And also when it comes to training and evaluating, right, we just want to keep experimenting with a lot of ML models, and obviously even that itself is a huge thing, like challenge. So that's about like collection to training the model. Like we have certain kind of challenges, but the actual challenge is once we just create a model, just taking that model to production. So that's where the actual challenge comes. So probably once you just have a model ready, you just train the model, you just find that it's just working good, and you just want to serve the model, like you just want to deploy that. So probably that's the hardest part. Like we as a data scientist don't want to involve in a lot of software engineering things. Like maybe it's little difficult to follow all the best practices to do. So obviously model serving comes into place. Even that is a little challenging task, like based on the application, we just want to deploy the model, we just want to create an API, front end, all the things we used to do. So that itself is another challenge, like deploying the model. So that's model serving. And obviously we just see the challenges right from collection to maybe some deployment, but the actual challenge start like once we just deploy the model. So obviously we all know, like it's just not about one way thing, as we just discussed. We have to continuously iterate on top of that what we just built. So for example, let's take you just build a simple image classification model, and maybe you're just getting something around 80 to 90% accuracy on your model. And maybe after like you just having some monitoring running on top of that, after 2 weeks, maybe you may check that, but the accuracy came down to around 60 to 70%. So what's the reason for that, right? That's the common problem face in ML in machine learning, right? Decreasing the model quality with time. So like we used to call like data drift. Probably most of you are aware of that. Like I just want to go a bit more into that. I just want to discuss some more what are the type of drift that we just have. We'll just discuss that, and also what are the solutions to that. Like we'll just discuss that. So yeah, as we just seen, when it comes to computer vision models, for example, let's say that's what I just learned, right? Unit can be object localization, detection, image classification, segmentation, whatever it may be the application. Obviously, once you just deploy the model after a certain kind of time, definitely the data will change. There may be certain kind of things that you might haven't taken care of when you're just trying to build a model. So obviously it results in data drift and obviously decreasing the model performance. And also to give some context, like probably another context, right? Like for example, let's say you just train a model in like let's say you just collect some images taken on summer, and for example you just test the models taken on some other season, right? Like for example, it's a winter, so there's some seasonality shift as well. So there's a lot of other factors to be considered when we're just trying to making the model better. So that's about like the data drift. Let's look at some of the type of data drifts that we encounter. One is covariance shift. Like it's just nothing but like changes in the features encountered in the in the production versus what you just trained. For example, let's say you just train a model on some low lighting images. For example, let's say images which are a bit contrast. And for example, and you just go to production and you just have some different kind of data set, some brighter images, etc. So there's a shift in the type of data that you just train. So probably that's covariance shift. And how to solve this? So there are some tools as well, like open source tools. Probably I'll just discuss that in a bit, like deep checks. There are some tools for to monitor as well. Like evidently, We'll just discuss that later. So that's how, right? Like a solution is probably to make it more generalized. You can just use some data augmentation tasks, like data augmentation on your data. And also, I just mentioned, like, we can just use some open source tools to check the robustness of your model. Like you can just check on different kind of test sets, or let's say different kind of images, and make sure like it just work on different scenarios as well. So that's the thing, like you can just follow that. And also label shift. So this is a common thing as well, and the reason for the decrease in the model performance. For example, let's say you just have like let's say some simple computer vision application, right? You can just relate it to any other application as well. Let's take cat versus dog classification, like which is a normal general basic computer vision application. So what if you can have some bias in your data? For example, let's say you have more kind of dog images in your trained data compared to cat. So there's a shift in your label, right? There's a mismatch in your data proportion of data. So that might be the reason, one of the reasons. So that's called label shift. And obviously, once you have that kind of variation on the labels that you just trained, it just failed to generalize the model that you just built. And also domain shift. So this is also one of the reason for the data drift that we just encounter. For example, let's say you just train an segmentation model for a particular country, right? Which can detect some, for example, let's say X-ray images, right? You just take some X-ray images. You just train some images related to age around 40 to 50. Now, when it comes to testing the images, for example, let's say you just test it like in the production level, you just got something around a different kind of images, which is different age level. So there's a shift in data, right? And also in domain, like the age level. So probably that's also one of the reasons. So there's a lot of things to be considered. I mean, once you just deploy the model. So as I just mentioned, it's not just about one way thing. You should continuously evaluate the model. You should just track the results, and also to find what's wrong with it, and you should able to come and just fix that. So that's probably to give some context, like what are some possible way, or like what are some possible reasons for your drift in model performance. And also, as I just mentioned, you can just use various tools and various techniques, like as I just mentioned, augmentation, to make the model more generalized, and also tools like deep checks for data validation, for model validation, to check how generalized your model is. So there are some other tools as well, like we'll just probably discuss that. So you can just use these tools and these some little techniques to iterate and to make a better model. So that's the thing. And also, obviously, we just seen, right, like to summarize what we just talked as of now, we just seen some like common challenges in ML lifecycle, right, from data collection to model deployment. And we just seen what goes wrong when you just deploy the model, and what are some different kind of problems, or let's say challenges happen even with computer vision, or let's say some general ML models. So, and also we just seen some little solutions for that as well. But let's focus on what are some best practices in developing models. So obviously, we have to version data, like probably more data versioning. Like if you just take an ML model, right, we just deal with data. It's just about data is the heart of like any machine learning model. So if you are just working in a team, or let's say if you're just working on yourself, you will be dealing with a lot of data sets, and also tracking that is really important, right? For example, let's say you just want to go back on what goes wrong. For example, if you just use some test data set, like some data set called A, to train a model, just works well. Then you just use some test data B, you just trained on that, it just doesn't perform well. So you should track all these things, right? Like what kind of data that you just use, what kind of results that you just got once you just train the model. So obviously, data versioning is the thing. It's the best practice to follow when you're just trying to build an ML model. And also, data and model validation, as we just shown in the previous slides, like how important it is to keep validate your data once we just validate your data once we're just getting into the model. So for example, let's say, as you just mentioned, right, data is the heart of ML, and whatever the data that you just got, that's what the model will be learning. So obviously, once you're just getting the data, you should have some validation on that. Like, you should be able to check, like, is this the right kind of data that I just want? So for example, it's like open source tools like Pandira, or these are some other tools as well. So you can just use that to validate the data, and also model validation. Like once you just build the model, you can just validate it. Like, is the model is generalizing on a different set of images, or let's say different kind of test cases, or like that. So you can just validate that as well. So that's also one of the good practice to have when you're just trying to develop the model. And also experiment tracking. Like obviously, machine learning in itself is experimenting. So you will be trying out a lot of different models. You will be trying out a lot of different data sets, a lot of different variables, all the things. Like keeping track of that is really important. For example, let's say you just want to go back and want to see what's happening with the model, what's causing this set of results, right? You should keep tracking the experiment, like whole machine learning, like model building thing. So you should be able to follow that as well. So probably for all these things, like for data versioning, data and model validation, experiment tracking, we'll just see some open source tools available, like a lot of tools available. We'll just look into that as well. And also, it's really important to build scalable pipelines. Like, for example, so as a normal beginner, or let's say a normal data center is working in Jupyter notebooks, it's really hard to make the code scalable, right? For example, if you just want to run over that, like if we just have a pipeline which can help us to make this process more easier, it would be really great. Like right, so having a scalable pipeline, like building on your like on project, whatever you're just building, it's really a good practice. And also like continuous monitoring, like as I just mentioned, it's not just about once you just deploy the model, you will be facing a lot of issues. You will be finding a lot of things that going wrong. So the monitoring that model, monitoring all these things will really help to come back and check what's going wrong, and you can just keep iterating over the cycle. So that's some really good practices to have. Now, like as I just mentioned, to summarize, there's a lot to handle, right, for in an ML a project, like data acquisition, feature engineering, preparation, monitoring, drift detection, logging, continuous training, all these things. Like there's a lot to handle as an ML engineer, or let's say data scientist, right? And also there are a lot of tools to handle as well. Like there are a lot of open source MLOps tools available. Like currently we're just seeing some rise, or let's say boom in generative AI space. But before that, we used to see, like we have this hype, or let's say even now it's having like, but probably a bit before, like we used to have this hype and like on recent MLOps tools. So you can just see a lot of open source MLOps tools to be considered. It's really important to pick a right one to our workflow. So we'll just look into that, some of the cool open source tools available. So as I just mentioned, right, data versioning is really important when you're just trying to keep track of what's happening with your data. And probably DVC is one such solution for that. Like you can just check that it just comes with, you can just collaborate with other workers, and also it just provide like Git like command like interface to create and version your data. And not just about code, you can just able to version your models, metrics, all the things as well. So DVC is a really cool open source tool that you can just check. And also this talk, I just want to present some more options for you to consider. Like there are tools like Neptune AI, Pachyderm, LakeFS, like you can just consider for data versioning. And obviously, as I just mentioned, right, testing and validating data and machine learning models is really important. And deep checks help you with that. Like probably you can just, once you just get the data, you can just run some checks on that. Like, is the data that I just got, is this the right set of that data? And also once you just once you just divide that data after before pre-processing, you can just check is the data like the train test set has having like a proper distribution of labels, especially with computer vision data. Like you can just test that validation as well. And also once we just develop the model, you can just evaluate the model with a deep check. So that's a really cool solution. And also you can just check evidently. That's another open source solution for tracking of all the things, like once you just deploy the model, that what you just seen, right? Like drift detection, like it helps you with that. Like evidently AI, you can just check which is an alternative for that. And also weights and biases. The previous talk, Soumik have mentioned all the things, like cool things that we can just do. Obviously, you can just track the experiments, right, from performance, model training process, all the things. Like it's really important to track the important, like the entire machine learning experimentation process, right? As I just mentioned, it's really important to go back for us. Like if you just track, if you just, it's really helps us to like go back and just check what's going wrong, what are the things that we just gone wrong. So it really helps us to keep tracking with the entire experimentation part, like model building. And also once you just deploy the model, you can just try to visualize that. And also you can just find the reports of how the model is performing. Like you can just check weights and biases for that. And also there are some other alternatives like Comet ML, ML Flow, Cube Flow, and Neptune. You can just check that as well. And obviously for you just seen, right? Like it's really hard as a data scientist to focus on like software engineering best practices to deploy models. So it's really a bit challenging. So having an open source solution for that is really cool. So Bento ML is another open source solution, like helps you to create that APIs. Like you can just serve the models. Either it can be batch serving or let's say online serving, like whatever it may be. You can just create that. And also it also like help you to standardize your entire machine learning workflow. So you can just focus on building the models, and these kind of open source tools like Bento ML, and also there are some other alternatives like TorchServe, Tensor, TFServe, or let's say KServe. Like there are some other open source tools as well alternative to Bento ML. You can check that as well. So the idea is to help you get an idea of what are some tools available in the MLOps landscape. So like hope you're getting that, like an idea of what it takes to these models. And also like to summarize all the things, like these are some really cool tools falling under different categories like data versioning, experiment tracking, model serving, model monitoring, validation, and as well as feature stores. So you can just check these tools as well. Like that's some cool MLOps tools. And also the real challenge begins, like we are seeing a lot of cool MLOps tools, but the real challenge is once you just want to bring, or let's say combine all these tools. For example, let's say I just want DVC for data versioning. I just want weights and biases for experiment tracking. I just want Bento ML for model serving. I just want deep checks for data and model validation, right? Bringing all those together, definitely if you have a platform or let's say another open source tool, it will be really cool, right? Like, so there are some other alternatives, other cool tools available as well. Like as I just seen, like the problem is just want to find the right tool for use case. Like selecting a tool from these a lot of tools, it's really hard. And also you will be continuously getting with every new tool, right? Like for the MLOps landscape is growing. Like you can just find some really cool tools in the market. So it's really hard to find the tool and also switch between them, right? Like there should be some kind of tool which will maintain all these workflows, manage all these open source solutions, open source projects. So that's where these tools comes into place, like ZenML, Kedro, Flight. So these are some tools that helps you to create a pipeline for your entire machine learning workflow, and also helps you to connect with these tools, like as I just mentioned previously. You can just connect with that, and you can just able to build an end-to-end solution for end-to-end solution for any kind of project that you just are building. So I just want to go a bit more deep dive into one tool like ZenML. I just want to explain you how it takes to create these workflows, or let's say how to create these pipelines, how to switch between these open source MLOps tools. All these things, we'll just go through that in a bit. So I'm just giving ZenML as a demo. Like you can just consider a Flight and Kedro as well. So they also offer these kind of things. So I just love ZenML, so I'm just using it. So I just want to give a bit more deep dive into how to create that models that probably you just have in your Jupyter notebooks to an end-to-end workflow, which combines with these all really cool open source tools and deploy that in your production. So as ZenML as a heart, like you used to have these kind of tools like a step and as well as pipeline decorators. So when you are just hope it's visible for you, like maybe it's too small, I don't know, like can you just confirm, anyone, like the code, is everything visible, or let's say
yeah,
I want to zoom it?
If you full screen it, you can make it out. I think on our side, I think you got to leave it small, but on our side, if we full screen it, we can make out the code.
Cool. So yeah, like for example, let's take this a simple example where we just try to we're just trying to load the data, we're just trying to build a model, we're just trying to train the model, and these are the two steps in our ML lifecycle. I'm just consider this as an example. Probably you can just include n number of steps, like n number of things that you just want in your pipeline. For example, let's say normalizer, evaluator, all the things that you just want. You can just create your own steps for different kind of tools, like to track experiments. You can just create another step decorator with another function for weights and biases, for a deep check. So you can just create in the similar fashion as I just shown you here, like with a step decorator, right? You can just see I just defined some to show you an example. I just defined some function and I just added this step decorator here. So this will help you to create that pipeline. Like once you this adding this decorator will help you a pipeline afterwards. Like you can just see here, I just use another decorator called pipeline, and I just define I just combine all these things steps here, like getting the data and training the model. So that's really simple, right? Like defining some cool steps using some decorators and creating a pipeline with some other decorator like pipeline decorator. So that's what it takes to build a pipeline. And also at the right side, you can just see the a simple image here, like what the pipeline looks like importing the data, training the model, evaluating the model. Probably you can just include what number of steps as I just mentioned. All you just want to do is add a step decorator, and once you just have that, and you can just create an entire pipeline for that. As I just mentioned, right, it's really important to have a good practice of creating an end-to-end pipeline for your ML project. Like it helps you to make code faster, or let's say just want to reiterate that it helps you with that, like having a pipeline. So it's that simple it is to create a pipeline with this tool like ZenML. And also as I just shown, right, like it's really cool to create a pipeline. And also the other important thing, the problem that we just talking, right? We just have really cool open source tools. Now we just want a place that we can just have all these tools and we can just pick from there. Like we just have this stack of all these cool MLOps tools. Now I just want to pick a tool that I just want. So you can just pick that. You can just do that with here. So you can just see it's a ZenML stack. It consists of all the stack components. So like experiment tracking for stack components for experiment tracking, and feature store, model serving, for all the things you'll be having ZenML stack components. So all these combinedly we used to call as stack, and used to have stack components. And in each stack component, right? For example, let's say you just have a stack component for feature store. So there are some really cool feature stores available, right? Like Tecton, C4ML. So there are some really cool feature stores available. So from that feature store, from that stack component, you can choose whatever the flavor that you just want. Like that's MLOps tool inside a stack component is called as flavor here. So you can just pick whatever the flavor that you just want here. So that's how easy it is to switch between that. And you can see, just to show you an example, once you just have some installation, some general installation of ZenML, you will get a local orchestrator and an artifact store. So a local orchestrator will help you to run the pipelines, right? You have seen, I've just defined some steps, pipelines. So orchestrator will help you to run all those things. And artifact store, you can see here, I haven't done anything. I just defined a step operator. So it will just store, right, all the data that the function is loading. The artifact store that comes with like the local artifact store, it will help. It helps to store all these artifacts, variables, data, etc. So that's a local stack that comes with an initial installation. Now the switch, right? The switch that you just want. I don't want local orchestrator. I don't want local artifact store. I just want to choose some cloud platform. So you can see at the right side, you just have some local stack on the top and production stack. So you can just choose, right? I just want to, instead of a local artifact store, I just want to store it in an S3 bucket. So, or let's say, I just want to use MLflow for experiment tracking. I just want to use weights and biases. So all these things you can just add to an existing stack. Generally, you just come up with local stack, and you can just add probably whatever the stack that you just want. I will just show you that as well, like how to add stacks with a couple of lines of code. So yeah, as you just seen, it helps you to select the tool that you just want. And as you just seen previously, if you just want an orchestrator for your ML workflow, if you just want a Kubeflow, or you just want track your experiments with weights and biases, deploy the model on with Bento ML, same ML artifacts on instead of local orchestrator, you just want S3 bucket, right? You can just choose that. And you can see, as I just mentioned previously, a type of stack components. You can see artifact, artifact store, orchestrator, container registry. There are different stack components available. So you can just choose from that. Like as I just mentioned, right? Orchestrator, like artifact store is a stack component. In that stack component, you will having different kind of flavors, right? For example, as I just mentioned, different kind of artifact store, like for example, let's say feature store, right? This and stack component. For example, in that feature store, you will be having flavors like feature form ML, as I just mentioned, some different kind of feature stores, right? So that's right. You just have the stack component, and from that stack component, you have a lot of flavors available. So you can just pick whatever you just want. So let's see how to do that. So it's just that simple to use, that simple to run with a couple of lines of code, like with a ZenML CLI command. Like you can just here you can see ZenML model deployer register. You can just deploy model deployer name. For example, let's say I can just choose here ZenML model deployer register Bento ML. So you can just create some deployer name, and you can just give the flavor, right? Whatever the flavor you just want. We are seeing there are a lot of flavors in each stack component. You can just choose what you just want for your use case. So that's how simple it is to pick one for your use case. And also, if you just want to delete one, like for example, let's say I don't want MLflow. I just want to delete that. Like you can just delete that, and you can just add another a tracking experiment tracker, like similarly. So that's how easy it is to switch between tools in ZenML. So that's what I just want to mention you about. So as you just mentioned, these are the flavors. Actually, I'm just talking about. This is the data validator stack. It consists of deep checks, evidently, logs, grade expectations. Like these are some cool data validators. So you can just pick one for your whatever the use case that you just want, whatever the tool that you just want. Like you can just pick that. You can just, as I just mentioned, you can create another step decorator with that use case, and you can probably create an entire pipeline to monitor and create that entire machine learning workflow. So that's data validator stack, and similarly model deployer stack. You can see there are some quite different flavors as well, like Bento ML, Selden, Queso, ML Flow, like you can just choose one. So that's about talk. Like to summarize what I just want to convey to you, like the challenges that an normal ML engineer face, like right from data collection to model deployment. What are some challenges? There are quite a few, and also it's really important to follow some best practices when it comes to developing the models. So maybe the other cool thing is there are a lot of open source tools available. So picking the one for our use case is really important. And probably I've just shown some of the cool tools for different kind of things, like different kind of model lifecycle fits into different kind of model lifecycle, like for experiment tracking, like all the things that I just talked about. So yeah, that's about thing. And also a tool that helps us to manage all these, like to bring all these tools, like the available tools together, and helps us to create an ML like end-to-end machine learning workflow. So that's about the talk. And also I would like to know if there is any questions or